Variables in research refer to the recorded information or characteristics under investigation by a researcher. These characteristics can encompass a wide range of data, such as age, mass, COVID vaccination status, birth gender, nationality, the number of employees in a company, a person's shirt size, small, medium, large, etc., and temperature. It is important to clearly know what kind of variable is being investigated, because that will determine how the data can be treated and what inferences can be made from the data. Variables can be broadly categorized into two main classes: categorical or qualitative variables and numerical or quantitative variables. Categorical, or qualitative, variables categorize the objects or subjects of study into groups or categories. These categories can be of two types: nominal or ordinal. Nominal variables lack a specific order and merely represent different categories. For instance, birth gender, nationality, and COVID vaccination status are examples of nominal variables. Nominal data is not suitable for numerical calculations like averages. You can count the frequency of each category or calculate percentages within each category. Ordinal variables, on the other hand, also categorize objects but with an inherent order. This order can be observed in attributes like size, as in shirt size, or levels of satisfaction, measured on a Likert scale. It's important to note that while Likert scales assign values to categories, this does not classify the data as numerical or quantitative. Numerical, or quantitative, variables, in contrast, provide measurable values with meaning. They can quantify characteristics, such as the number of people, an individual's mass, age, or the temperature of an object. Numerical variables are further divided into two categories: discrete and continuous. Discrete variables are measured only in whole numbers or integers. Examples include the number of employees, defects, or items produced, etc. Continuous variables encompass values that can include decimal points. For example, mass might be expressed as 52.357 kilograms, volume as 18.72 liters, or temperature as 37.6 degrees Celsius. All numerical variables may also be classified as either interval data variables or irrational data variables. Interval data variables, temperature, measured in degrees C, does not have an absolute zero and is thus an interval data variable. 0 degrees Celsius does not mean there is no temperature. Other examples of interval data variables include pH, IQ, and credit scores. Interval data variables allow for a wide range of statistical calculations, including the mean, standard deviation, and various parametric tests. You can perform arithmetic operations like addition and subtraction. Ratio data variables have a meaningful 0 point, signifying the complete absence of the variable. For instance, 0 people in a room means that no one is present, illustrating a ratio data variable. Ratio data variables allow for all arithmetic operations and a wide range of statistical calculations. You can calculate the mean, standard deviation, and perform parametric tests. Ratios, proportions, and percentages are meaningful. It's crucial for researchers to identify the type of data they are working with, as this determines the appropriate analytical methods they can employ. For example, it wouldn't make sense to calculate averages for categorical variables. Instead, we might express birth gender as a percentage, such as 49.8% of births are male. However, for continuous numeric values, we can calculate averages, such as the average mass of all male babies born is 3.2 kilograms. Researchers also gather information that doesn't fit the traditional variable definition but is vital for identification. These pieces of information are called identifiers, and they include data like student numbers and employee numbers. Understanding the type of data you are working with is crucial for selecting appropriate statistical techniques and making valid inferences. Each data type has its unique characteristics and limitations, which determine the range of analyses and inferences that can be made.